Okay, Assalamualaikum and good morning. Okay, today we will start a new chapter, okay, which is chapter 3. Okay, chapter 3 will focus on three-phase system. Okay, what is three-phase system? So basically, three-phase system is just a single-phase system connected together to form a one system. Okay. However, to maintain the constant power flow, the three single-phase circuit must be operated with the same voltage and current in each phase, but receive different electrical degree. Okay. So basically, what is that mean is that, okay, so you have a AC system like this. Okay, you have load here. Okay, and okay, the problem is that for large system, this not enough. So you need to have multiple AC system. Okay. So to support a large system with large power requirement, you need to have multiple source. Okay, you cannot just handle one because the current will become too large if you use only single. So to overcome this problem, you combine all of these together. Okay, you combine this and you will become a system. Okay, so you have to combine the neutral part together. Okay, it will become like this. Okay. So it will become a three-phase system. Okay, for this one, okay, the voltage needs to be the same. For example, if you choose the voltage is 240 volt, this one also needs to be 240, and this one 240. Okay, the voltage needs to be the same. However, the phase needs to be different. Okay, for this one maybe 0 degree, this one as a reference. Okay, this one needs to be different from this, but because of the three-phase system, okay, one cycle is 360 degree. So because three-phase system, so equals to 360 divided by 3, you get 120 degree per phase. So this one is negative 120 degree. This one is okay. Okay, this one is negative 120 degree, and this one is negative 240 degree. So each of these phase is 120 degree out of each other. So basically this one is just 240 angle 120 positive. So if you draw this in the plane, okay, something like this. So you have one is here. This one is 240 degree 0, and one is here, which is 120 degree. This one is also 240 volt. Okay, and another one is here, is 120 degree. Okay, this one also 120 degree. Okay, so the voltage need to be 120 degree apart from each other. So that is what this statement means. Okay, this is what it shows. Okay, so if you can see here, it is 120 degree from each other. Okay, this is designed by the stator. Okay, what is stator is actually, okay, in a generator, Okay, you have generator, you have motor. So generator is basically this one. Voltage source is basically from a generator. Okay, what is generator? It's just a some kind of motor. Okay, you have generator. Okay, something like you can Google it. This one is basically a power source. Okay, okay, this one is a stator. Is static, doesn't move, and another one is rotor. Okay, this one is rotor. Okay, rotor is inside the. Okay, this is one generator. Generator has stator and rotor. So at the stator, at the outer side of the generator, okay, so it will place the wire. Okay, this is the wire for A. Okay, goes in, goes out. Okay, this one a wire for another phase. Okay, the negative 120. Okay, and this one also another wire. So that is how you get 120-degree apart from each other. Okay, so you just place the wire at the stator here. Okay, this one and this one. Okay, B maybe goes into, and B this one is goes to the other side. So this one maybe goes into, this one maybe goes outside. Okay, that is how you arrange a wire for three-phase system in a generator. So basically, if you look here, okay, this one is basically a generator. Okay. So what is the waveform? The waveform is basically like this. Okay, it's like a ribbon. Okay, so you have this one is red phase. Okay, okay, this one is okay. So this one is another phase, and another one here is another phase. So you have three phase. Okay. So this is how the waveform looks for three-phase system. This is the voltage. Okay, V and E is basically the same. This one is a voltage. This one is actually potential. Different. Okay, also a voltage. Usually this one used for power supply. And voltage is used for both. Okay, load and power supply. So if you meet E, means that it's just a voltage. The unit also voltage. Okay, so don't be confused. Okay, this is the waveform. Okay, make sure you know how to draw this. Okay, it is important for you to know how to draw this. Okay, okay, usually, okay, because there are three phases, you need to label it properly. So what is the labeling used for three-phase system? Okay, there are two types of labeling. Either you can use A, B, C or R, Y, B. ABC is just ABC. Okay, just follow the sequence. RYB means that red, yellow, blue. Okay, make sure you take note this, because this note provided is not completely show the meaning of this. Okay, so ABC is just a sequence ABC. Okay, and RYB is just red, yellow, blue. Okay, this one is used because of the. Okay, this is just basically the official. Okay, TNB. Okay, the power supplier use this system because of the wire, color of the wire, because this one is easier to identify, red, yellow, blue. And this is why to take electricity, to take any course in electrical, you cannot have color blind. Okay, because if you don't connect the connection properly, the system will destroy. Okay, it will break down the system if you're not connected properly according to the color. So you need to know how to write this. Okay, so VA, sine, WT, and okay, for VB, okay, this one is sine WT and minus 120. Okay, and VC is just sine WT minus 240, or you can use a positive part. Okay, this is the same. Okay, how to get this is just 360 minus, okay, minus 240, you get 120. Okay, you need to know how the angle. You need to remember back how to do trigonal angle. Okay, angle placement. So after that, you know how to write the time domain. Of course, you need, when it comes to AC circuit, you need to know the phasor domain. So basically, to convert this into phasor domain. So to convert this, okay, you can see here, okay, VA, this one is maximum value, okay, max value, okay, this one is max value, this one is max value, and you can see that here is V. It's different, So V is basically, okay, so this one is not actually accurate, so I just, okay, I give you example here. So how to convert from time domain to phasor domain. So for time domain, okay, for time domain, for red, for example, if you use VA in time domain, make sure you use correct term. VA T equals to, okay, VA, okay, Vmax. Okay, so assume I use Vmax is 240. Okay, sorry, 340. Okay, sine WT. Okay, and okay, yellow. I don't have color yellow. Okay, VB is, okay, 340 sine WT. Make sure this one and this one is the same. If you use cos, use cos. If you use sine, use sine. 120. And make sure you use clockwise. Okay, you have to use clockwise. Okay, so means that 0, 120 degree, negative 120, negative 240. And VC is T340 sine WT minus 240 degree. Okay, make sure counter, make sure it is clockwise. 0, negative 120, negative 240. Okay. And then you have to convert this to phasor domain. So how to convert this? Same as before in chapter 2. So make sure it's capital first, then 340 divided by square root 2. Don't forget VRMS. Okay, the angle is 0 degree. How about VB is VB, capital letter, 340 divided by square root 2. Okay, so remember RMS. Angle negative 120 degree. And VC is equal to 340 divided by square root 2, angle 100 negative 240. Okay, this is the first thing that you need to know how to convert this. Okay, you need to know how to convert into phasor domain. Okay, so three-phase system. Okay, next thing you need to know is how to draw in phasor domain. Okay, so how to draw it? How to draw the phasor diagram? Okay, okay, you have the phasor. Okay, now you need to draw phasor. Okay, diagram. So how to draw this is just basically this one is VA 340 divided by square root 2 is 340 divided by square root 2. I think it's just 240 if not mistaken. Okay, so 240. Okay, so then this one is VA. Next, this one is VB. Okay, this one don't forget to put negative 120 degree and 240. Don't forget magnitude and angle. Okay, and last one is VC. This one is 120 degree or 240, negative 240. It's the same. So also don't forget 240. Okay, make sure you know how to draw the phasor diagram from the angle. Okay, the next part is sequence. Okay, you need to know the sequence. Okay, you can see here. Okay, basically there are two sequences. Okay, there are two sequences, either positive or negative. So basically, what is the difference? So positive and negative. Okay, if you use the ABC system, positive sequence is just A, B, C. Okay, and if you use negative sequence, it's just is another way around. So A, C, B. Okay, just flip these two. Okay, A is still maintained because A is the reference. Okay, if you use RYB system, make sure you know both systems because sometimes they use ABC, sometimes they use RYB. So this one is RYB, red, yellow, blue. For negative system is use RBY. Okay. Also, this one maintain, this one flip. Okay. So how to draw it? Okay. If you draw this, okay, this one is VR. Okay. Okay, this one also VR. Okay. Make sure R is the reference, 0 degree. Okay, this one is VY. Okay, negative 120 degree. And this one is VB. So 120 degree positive. But for this case, you just flip the tail. Okay. So VB. Okay. Okay, you can see here. VB, VY is flip. And VY. So this one is negative 120 degree. This one is 120 degree. Okay. So the angle here, okay, so VR equals to, okay, V theta 0 degree, Vy is V theta negative 120 degree, okay, Vb is V 120 degree. But for this one, okay, for positive sequence, okay, Vr still the same, it is a reference, and Vy is Vb is negative 120 degree, and Vy is V 120. So you just flip this, okay, this one, okay, that is the difference between positive sequence and negative sequence, okay. So you can read this, okay. So Vr lead Vy, okay, Vr, okay, Vr here lead Vi, Vy. So make sure Vr is at front of the Vy, okay, and lead Vb, okay, Vb also lead, okay. So this one produced when roto rotates in counterclockwise. This one usually in theory, so make sure you know counterclockwise direction, okay. So the rotor, remember the generator? The generator has stator and rotor. Okay, if the rotor spin at counterclockwise, okay, it will produce positive sequence. Okay. How about negative? Okay, Vr lead Vb. Okay, is flip. Okay, remember I said before, is flip. Okay, and this one caused by the rotor in clockwise direction. Okay, clockwise direction, and this one counterclockwise direction. Okay. Okay, this one is also important. For this class, we use positive sequence. Okay. For this course, make sure you use positive sequence. This one, R, Y, B. Okay. So make sure you use the correct one. Okay. You use this one. Okay. Use this. Never use this one, except if the question asks. But usually they will not ask negative sequence because the step is a little bit different from the positive sequence. Okay, you remember, use this one. Okay. Okay, next part of the study is star delta. Okay, so for theory, you need to memorize this. Okay, star delta. What is the use of star connection? Okay, for system that high voltage and low current, you use star connection. Okay, for star connection, there are two types, either 3-wire or 4-wire. Okay, so basically extra wire is just a neutral wire. So I will show you later what is neutral wire. And for delta connection, you need to know what is the use. Okay, for high current, low phase current. Okay, high line current and low phase current. Okay, and there is no neutral line. So make sure you know this. What is the use of star connection and what is use of delta connection? So basically, this is a star connection. This one is delta connection. Okay, how to draw? Okay, it is important for you to know how to draw this. Okay, Okay, first there are generator and load. Okay, they are star connection and they are delta connection. So you need to practice how to draw this. Okay, for generator, I focus on generator first. Okay, for star connection, okay, first you have to draw this type of triangle. Okay, okay, you make sure that you have this kind of triangle. Okay, for star is like this. Okay, oh sorry, for star is like this. For delta is like this. Okay, make sure you know. Okay, so then you put like this, and then take here and take here. Lastly, take here. This one is A, B, and C. Okay, positive sequence. Or if you use R, Y, B, choose one only. Okay, choose one. Don't use both sequence. Okay, either A, B, C or R, Y, B. And then, okay, for star, remember that the note said that there are two types, either three phase, three line. Okay, this means three line, 1, 2, 3. Okay, another one is 4 line, which is just a neutral wire N. So it is from the center. Okay, this is how to draw star connection. Okay, how about delta connection? So delta connection is just basically, so you have to draw inverted triangle. Okay, okay. Oh sorry. So I have to check back. Okay, for delta here. Okay, okay, inverted triangle. Okay, all right. So you draw here. Okay, then you draw triangle. Okay, so like this. And this one is A, this one is B, this one is C, this one is R, Y, B. Okay, either don't use both. Okay, that is how to draw delta connection. Okay, how about labeling? So for delta here, so this one is V A N or V R N. So this one is neutral. Okay, so this one is, because here to here is V, so VB, VBN, okay, or V, sorry, too many, okay, I delete this first. Okay, so don't forget the positive and negative. Okay, positive, negative. For neutral, always put negative side. Okay, always negative and neutral. Okay, this one also negative. Negative. This one is positive. This one is positive. So this one is V B Y or V Y N. Okay, V B N or V Y N, or this one is VCN or VBN. Okay, make sure. Okay, for if you look here, VBAN, positive, negative. Okay, V positive, negative. So VAN. VBN, VCN. Okay, and the direction of current, of course, always goes out from positive. Okay, goes into here. Okay, make sure it goes into the line for generator. Okay, that is how to draw it. Okay, how about delta generator? Okay, so focus on voltage first. Okay, for this case, okay, you have to use V, R, Y, V, okay, Y, B, V, B, R. Okay, remember R, Y, B or A, B, C. Make sure you use V, R, Y, V, Y, B, V, B, R. Okay, or okay, V, A, B, V, B, C, and V, C, A. Okay, make sure you move like this, and then like this. Okay, so remember VRY, VYB, VBR, or VAB, VBC, VB, VCA. Okay, now how to label this inside? So this one is AB. So VAB, positive, negative, VAB. Okay, for this one is okay BC. Okay, positive sequence always increasing. Okay, BC. Okay, positive, negative. Remember, V positive, negative. Okay, and VCA. Okay, C because we cannot use D, move back to A. Okay, VAB, VC, CA, and C is where here positive and negative. Okay, C is here. If you look here, this is C. Okay, and A. So V positive, negative, CA. How about the current? Okay, if you look current, okay, for generator, always leaving the generator. Okay, remember at line, this is line. Okay, this one is line. Okay, this one is phase. Okay, this one is phase. This one is line. Okay, so for this current, okay, remember for generator, current always goes to positive, out of positive. So this one is IAB. Okay, IAB is just for generator is IAB is current moving from B to A. This is for generator. For motor is IAB. Okay, like this. This is generator. This one is load. Okay. Make sure you differentiate this. Okay. For this case is this one and this one is always go out to positive. This one is IBC. This one is ICA. Okay. Okay. That is how to draw a generator star and delta. And you need to know the different. Okay, for this case, okay, if you check here, here and here, you get V, A, B, this one is line. Okay, it's because it is between line A and B. Okay, if you check here, this one is V, B, C. B, C. This is because of the line. You check at the line. And this one is phase. Okay, this one to here is phase. VAN is just phase. Okay, I will show you later here. Okay, same here. Okay, this one is phase voltage. Okay, from here to here is phase voltage. And for current, if you look here, this is line because it is at line. Okay, this is at line, so line current. This one is IA, IB, IC. Okay, this one is phase current. Okay, so phase is IAB. Okay, so make sure you differentiate this. Okay, we take break for 10 minutes. Okay, and we continue with load. Okay. Okay, I have to repeat back. Sorry for the class in the morning, in the evening. So if you look here, okay, can I repeat back? Because it is it's important for you to remember everything. So I repeat everything back. Okay, thank you for remembering record. Okay. So for load, first you have to draw this, and this. Okay, and remember, okay, for this type is impedance, means that it has complex component. Okay, either L, N, or C. Okay, this one is for impedance, and this one for resistor. Okay, make sure you know the difference. Okay, so draw this, of course, the same. So there are A, this one is B, this one is C. Okay, or if you want to use R, Y, or B, okay, you can use either. You cannot use both, you can have to use either. And then for voltage, okay, remember this is neutral, and neutral always negative, 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 positive, positive, positive. Okay, this one is V, A, N. Remember, V positive, negative. So this one is V, B, N, and this one is V, C, N. Okay. Okay, so you have this one is called phase voltage. Okay, so this is phase voltage. So there are also phase current, line voltage. Okay, this is phase voltage. Okay, this one is line voltage. Remember, R, Y, B or A, B, C always goes increasing. Okay, positive sequence. Okay, so remember VAB. Okay, because we use positive sequence VAB. Okay, positive, negative. Okay, VBC, positive, negative, and VCA, positive, negative. Okay, that is how you label a line voltage. Okay, different from phase voltage. And if there are another way to show positive, negative, you use arrow. If you use arrow, you use this one, negative to positive. So VAB is positive to negative, VBC is here, and VBA is here. Okay. So negative to positive if you use arrow symbol. If you use positive, negative, you can use like this. Okay, there are two ways to show the voltage. And how about the current? For current, for star connection, there are only phase current or phase voltage. This one is IA. Okay, this one is IB. This one is IC. So for generator, if you can see here, current goes out of generator, but for load goes into the load. So you have to draw. Okay, when you answer question, you have to draw. Okay, it is important for you to draw. Okay, next for load and delta connection. Okay, for load delta connection, of course you have to draw. Okay, pyramid. Okay, pyramid type. Okay, then like this. Okay, then this one, and this one. So A, B, C, or okay, R, Y, B. Okay, you can use either. Okay, for voltage in delta connection, there are only phase voltage. Okay, V line is just equal to V phase. So same as here, use the sequence A, B, C. Okay, positive, negative, VAB, VB, VBC. Okay, okay, V positive, negative, positive, negative, and VCA, VCA, negative, positive, positive. Okay, and don't forget the arrow is moving from negative to positive. So if they use arrow, make sure you understand what is the meaning of the arrow. Okay, negative to positive, negative to positive. Okay, sometimes question use arrow, sometimes question use positive, negative. So make sure you know where is positive, where is negative. So for delta voltage, line voltage, and phase voltage is the same. Okay, but for current, V line not equals to V phase. Sorry. I line not equals to I phase. Okay, we start with I line first. Of course, goes into the load. This is I, A, I, B, I, C. Okay, this is line voltage, line current. Okay, when goes here, it will become phase current. Okay, so remember, phase current is I, A, B, I, B, C, and lastly I, C, A. Positive sequence A, B, B, C, C, A. So if you look here, IAB is just from A to B. IAB. Okay, this one is B to C. I, B, C, and then this one is I, C, A. Okay, remember that I say generator is from B to A, but for load is A to B. Make sure you know the difference. Okay. So basically, okay, this is how to draw. How to draw the star delta connection for generator and load. So you need to know how to draw, and it is a must important thing to do before you answer the question. You have to draw to answer to understand the question. Okay. So this is what is star. Oh, this is what star delta connection. Okay, you have to know how to draw this. Okay, so this one is a, okay, you can see is star, and this one is delta. So basically, you can, okay, from this, you can connect any way you want. If you have star generator, you can either connect to the load star or load delta, or if you use delta connection, okay, you have delta generator, you can use load or star load or delta load. So basically, there are 4 types of connection. Okay, and they usually write like this: star, delta, star, star, delta, star, and delta, delta. So this is generator, and this one is load. So you need to know what is the meaning of star star, star delta, delta star, delta delta. And for star star only, you can have neutral wire. Okay, remember that I said like this. Okay, you have load like this. Okay, this one and this one. Okay, star connection, either you have through 3 line, okay, 3 wire or 4 wire system. Okay, so make sure you know all of this. Basically, there are 4 types, and one of the type have two category. Okay. Make sure you know how to draw all of this. Okay. So for this one is okay. Okay. This one is star delta. So you need to know how to draw everything and how to label everything properly. Okay. So this one is I show you before. Instead of using positive, negative, you use arrow, okay, to represent the voltage. Okay, now we move on to the next part. Okay, so let me break the video first. Okay,